Hello and welcome to the first math video of this channel. Today I'm gonna give you an introduction to factoring polynomials of one variable, a very basic approach. What I will be doing in this video is giving you some basic definitions, a statement of the fundamental theorem of arithmetic, teach you how to factor polynomials of first degree, and teach you how to factor polynomials of second degree, and give you some tools to try to factor polynomials of higher order. In this video, I will only cover these three topics, and I will give you the instruction to factor polynomials of second degree in my next video. So let's start with some basic definitions. What is a polynomial? The word polynomial comes from poly, that means many, and nomial, that means term. So polynomial means literally many terms. What is a term of a polynomial? This is a term of a polynomial, are the little chunks that are separated by plus or minus signs. So this polynomial here have three terms, 1, 2, and 3. And this polynomial here have only two terms. This is the first three terms as well. This is the first term, this is the second term, and this is the third term. Each term can have constants. A constant is just any real number. It could be 6 over 5, the square root of 8, 0.2, even something as crazy as 16 over pi. This is a number. So constants are just number the terms. The variables, in here the variables are x, here there are x, y, and z, a, b, c, and you could have as many as you want. But in this video I will only approach polynomials of one variable, and the exponents of the variables can only be positive integers greater than 1, greater or equal than 1. So you have here that the exponent is 2, but it could be any integer greater or equal than 1 that you like. So this is the definition of a polynomial. What is not a polynomial is, for example, something like this, because you see here that the exponent of the variable is not an integer. So this is automatically not a polynomial. This is also not a polynomial because this exponent is not an integer, and this is also not a polynomial because the exponent is negative. It must be positive and greater or equal than 1. And if you have something like this, an infinite sum, this will also not be a polynomial. All polynomials must be finite. So if you have something that is not finite, it's not going to be a polynomial. Now, what is factoring? Factoring is writing a number or another mathematical expression as a product of several factors, usually smaller or simpler objects of the same kind. What is the degree of a term? The degree of a term is the sum of the exponents of the variables. So if we return here, we could see, for example, this term has degree 2. This term right here has degree 3 because it's the sum of the exponents of all its variables. So this is x to the power of 1, y to the power of 1, and z to the power of 1. So it will be 1 plus 1 plus 1 would be 3. This term will also have a third degree monomial, and this term will have 20, 20 plus 2 plus 22 plus 12 plus 165 plus 2 as its degree. The degree of a polynomial is the maximum degree of its terms. So in these examples, the degree of this polynomial would be actually 3, because this is 3, this is 3, this is 2. The maximum between 3, 3, and 2 is 3. So the degree of all this polynomial will be 3. The degree of this polynomial would be whatever the sum of these terms are. So it would be a really high degree polynomial. Factoring polynomials is writing polynomials as a multiplication of other simpler polynomials, usually of smaller degree. So you must be asking yourself, if I have a polynomial of degree 1, how can I factor it? Well, you could express a polynomial of degree 1 as a multiplication of another simpler polynomial of degree 1 times a polynomial of degree 0. What is a polynomial of degree 0? It's a polynomial with no variables. That is, only a constant, a number. But before getting into that, I will state the fundamental theorem of arithmetic. Every integer greater than 1 is either a prime number itself or can be expressed as the product of prime numbers, and this representation is unique up to the order of factors. What is a prime number? A prime number is a number that can only be divided by itself or by 1. So for example, 2 is a prime number because 2 is only divisible by 1 and 2. 3 is a prime number because it's only divisible between 1 and 3. 4 is not a prime number because 2 divides 4, and 2 is not 4 or 1. When I say this representation is unique up to the order of factors, I mean, for example, this number would be 2 times 3 is 6 times 4 is 24. So I'm saying this is the representation in prime numbers of 24. And this is also a representation for 24 in prime numbers. But these two representations are considered equal because they have the same terms. So it doesn't matter the order in which you write them. The representation of 24 is unique because it's the representation given by 2, 3, and 4. Okay. So in order to be able to factor polynomials of first degree, you must understand very well how this theorem applies to common numbers. So the first thing I will ask you to do is to please take a piece of paper and try to write down the prime representation of each of these numbers. If you'd like, please pause the video and return when you've done it to check the answers. Alright, good. These were the answers for these numbers. So the prime representation of 62 is only 2 times 31. 31 is a prime number. And the same goes for the rest of these examples. Now, let's see how to factor polynomials of first degree. In order to factor polynomials of first degree, we must understand first the distributive property. This is the distributive property. It's the property that says that you can distribute a variable between a sum in parentheses. And this is usually what all the people teach, but it's very important to realize this also works backwards. That means if you have an expression like this, you can transform it into expression like this. So if you have x times y plus x times c, that is equal to x times y plus c. You could take the terms that are similar, you could take the variables that are similar in these two terms and take them out of the equation and group the remaining terms. Why can I do this? Well, if we take a look at the definition of multiplication, let's say we are multiplying x times w. We know that multiplying x times w is the same as adding up x w times x plus x plus x plus x, a total numbers of w times. And that is also equal to adding w, a total of x times. So it's also equal to w plus w, a total of x times. So when we have x times y plus c, by definition of multiplication, that would be equal to adding up x, a total number of y plus c times. So that would be x plus x plus x plus x, a total number of y plus c times. Now, if we have this expression that is just y plus c terms adding up one after another, we could write them first, the first y terms plus the last c terms. And these two expressions are exactly the same. I'm just noting that I could separate these terms into the first y terms and the last c terms. Now, because of this exact same definition, I could say this expression right here is equal to x times y, because it's adding x, y number of times. So I have x times y plus x times c. So, because of the very definition of multiplication, we could assert the distributive property. It's very important to read it backwards and take note that when you have some expression like this that shares something, you could also take that something, whatever it is, and take it out of the equation to make it multiply the rest of the equation. All right. So every polynomial of first degree is something like this. In here, a and b are constants. That means a and b are numbers, and the only variable will be x. So you could ask yourself, why should it be like this? Couldn't it be a polynomial with many more terms such that all the terms have degree 1? Well, yeah, you're right. It could be something like this, but because of the distributive property that I just show you, you could take this term and group the x. You see, in here we have an x, in here we have an x, so we could actually take the x outside and multiply a plus c. So that's exactly what we have here. If we have ax plus cx plus b, we would have a plus c times x plus b. So what I did here was use the distributive property. And once we have this expression, we could rename this variable. Remember that a and c are only numbers, so this would also be a number, a constant. I could name it whatever I like it. If I want, I could name it a bar. A bar is equal to a plus c. And you see this expression has the exact same form as this expression. So all the polynomials of first degree can be expressed in this form. To factor polynomials of first degree, you should write the constants, a and b, these two constants, as products of prime numbers using the fundamental theorem of arithmetic, and then use the distributive property. For example, let's say I'm asking you to factor this polynomial. So you see that only one term of this polynomial has a variable, and that this term has degree 1. So this polynomial is a polynomial of degree 1. What you should do in order to factor this polynomial is to write down this number and this number in their prime representation. So the prime representation of 288 is 2 to the power of 3 times 3 to the power of 2 times 4. And the prime representation of 2016 is exactly the same, times a 7. Now, when you have this expression, you should note these terms are common, these numbers are common in these two terms, right? 2 to the power of 3 is in both terms, 3 to the power of 2 is also in both terms, and 4 is also in both terms. Using the distributive property, we can take them out of the equation and make them multiply x plus 7. And that's exactly what we did. We take these that were the common terms between these two terms and made them multiply x plus 7. Now, we only have to write this expression as a regular number. So we already saw that this is 288 times x plus 7. And we've finished factoring this polynomial. If you see, we have here a polynomial of order 1, and now we've expressed it as the multiplication of a polynomial of order 0, that is 288, 288 is a polynomial of order 0 because it's only a constant, times another simpler polynomial of order 1. X plus 7 is also a polynomial of order 1, but is simpler than this expression. So we've done factoring this particular polynomial of first degree. So please take a piece of paper and try to factor these first degree polynomials. If you want, pause the video and come back when you've done. Okay, let's check our answers. So these should be your results. If not, please try again. And that's all there is to know about factoring first degree polynomials. In the next video, I will talk about factoring second degree polynomials, but I will cut the video here because it's already 16 minutes long. Thank you very much, and if you have any question, please feel free to write it in the comment section below. Thank you for watching. Bye bye.